Hello everyone, this is Simin from Informatica Global Customer Support Team. In this session, I'll be explaining about configuring an Amazon Redshift scanner in CDGC. These are the main points. I'm going to explain it in this presentation. I'll begin with the Redshift overview. In addition to that, object extraction, prerequisites, profiling, connection creation properties, and we'll conclude with a demo presentation. Let's begin now. AWS Redshift. It stands for Amazon Web Service Redshift. It's a data warehousing solution from AWS to store and query large volume of analytical data. Do you know how does it differ from a traditional relational databases and Redshift? Traditional databases are designed to store individual transactional data and records, whereas the data warehouses are designed to store aggregated data from multiple sources like relational databases and S3 buckets. Next is working on Redshift. Here in Redshift, we'll be using clusters to perform all the operations. This cluster consists of a leader node and a multiple compute nodes. The leader node distributes jobs to the compute nodes, which each have their own memory, CPU, and disk storage. Compute nodes are divided into slices, with each slices being allocated to a portion of the CPU, disk space, and memory available. These resources are used to process the portion of a job submitted to the node slice. Once the compute process is complete, the node aggregates the result from each slice and sends it back to the leader node. So once the leader node receives the job results from all the parallel nodes, it aggregates the result and passes it back to the client who initiated the query. Now let's see how to connect to a Redshift. So when you instantiate a Redshift cluster, you are provided with an endpoint for connections, which is combination of URL and a port number. You use this SQL endpoint to connect your application to Redshift. Any application with a JDBC or ODBC industry standards driver can be used to establish a Postgres connection to the Redshift. These are the supported file types in Redshift. Let's split it here into two. For metadata extraction, we support databases, schema, table, external table, view, materialized view, function, procedure, and column. And for profiling, we support table and views. And before we configure into the scanner, we need to make sure all the preconditions are met. Here are the list of preconditions. The first one is the connectors. We need to make sure we have a valid Redshift v2 connectors in your runtime environment. To enable the connectors, you can click on the ellipses on the extreme right of your runtime environment and choose enable or disable service. And on the pop-up window, go to the connectors tab and verify the connectors as chosen. Then you need to make sure the required permissions are given for the users to authenticate. If you're performing only metadata extraction, then you need to have a read permission on the Redshift external sources, select permission on the list of metadata objects, and finally the permission to show external tables on the tables that you wanted to process. And I will show you the list of metadata objects where the select permissions are required. So these are the meta tables you wanted to provide select permissions in order to access the metadata. For profiling, you need to have another set of permissions required. Those are put objects, get object, delete object, list bucket, and the last, the get bucket policy. Okay, let's move on to the connection creation page. So in the administrator service page, you will be able to see a option to create a connection. So you need to choose the connection type as Amazon Redshift v2 in order to create a Redshift connection. So the name, you can name it as per your wish. And the runtime environment should be up and running. And as I mentioned before, it should have a valid Redshift v2 connectors. And the JDBC URL should be provided here, and username, password. Then the access key and shared key, secret key should be added here. So once you provided all these details, you'll be able to see a test connection option in the connection creation page. Click on test connection and validate whether the connection is working fine or not. Let's move on to the demo. There I can show you the scanner configuration steps. This is a metadata command center service page. Click on new button to create a new catalog source. From the list of catalog sources, just type Redshift here and you'll be able to see the Amazon Redshift catalog source creation page here. Just click on create button. It will take you to the catalog source creation page. So for the demo purpose, I've already created a catalog source and we will explain it with that. Infra Redshift demo. I have already named it as Infra Redshift demo here. Okay. This is a registration page. You can choose the connection we created in the administrator service here, and you can click on test connection to make sure that the connection is working fine. Then click on next button and let's move to the configuration page. So under the configuration page, you can see the option for metadata extraction, profiling and data quality, classification, relationship discovery, and glossary association. Okay, by default, it will be selected in the metadata extraction page. Here, you need to choose a runtime environment which is up and running, and metadata change option. Here, metadata extraction option will be selected by default here. So to configure the metadata extraction, first you need to choose the working up and running runtime environment here. Then metadata change option is the next option you can see here. So by default, the value will be a retain, and if you wanted to remove something from the already extracted data, then you can choose delete option here. So in addition to that, we have an option to filter the records as per your requirements. Only the required asset details can be fetched using the filter here. Here, I have applied a filter to scan all the metadata which are under the schema repro underscore test2. Below, you can see a list of options under the configuration parameters section. If you want to extract a programmable objects such as stored procedures, functions, and packages, then you can choose this option here as yes. And if you are using variables in the programmable objects, then define those variables here under the default variable value section. Our scanner doesn't read table or view content by default. If you wanted to use the content of the meta tables anywhere within the PL SQL, then you can add those names here. But you need to verify the user has a select permission on the meta tables before the scanner execution. And this completes the metadata extraction side of Redshift. Let's move to the profiling side by just clicking on the profiling tab here. Here, choose a runtime environment which is up and running. Then the filter condition you can apply based on your requirement. By default, the value no will be applied here. So in other words, it will be profile all the objects which are extracted through metadata extraction job. So you can choose yes to apply the filter to profile the data. You can use include or exclude operation to filter the records. Here you can see a list of parameters available to configure. We'll go with one by one. The first one is modes of run. This option determines the types of data that you wanted to profile. If you choose keep signatures only option, the data profiling task collects only aggregate information such as data types, average, standard deviations, and patterns. And if you choose the second option, that is keep signatures and values, then it will collect minimum value, maximum value, frequent values, etc. Next, profiling scope. This determines whether we wanted to run this profiling on this entire data or only from the delta data. So if it is incremental, it chooses only the delta records. And if you choose the full, it will profile the data completely. If you enable the incremental profiling and run the job for the first time, then it will consider it as a full load by scanning the entire metadata. And if you wanted to limit the number of rows to be profiled, then you can use the sampling type option here. You can choose all rows or limit n rows. And if you choose limit n rows, you'll be able to see this option, number of rows to limit. and based upon your requirement you can just adjust the value here. Then you need to provide the path of S3 bucket which is used to stage the data here. So once it is done, then you can just click on save button here and you can run this catalog source configuration. Here is the stats of execution. The first part is the metadata extraction and the second part is the data profiling. Let's jump onto the governance and catalog page to see the extracted profile data. This is the extracted details of the catalog source here. You can see database, schema, table, and column level details here. Let's pick one of the field to check the profiled data. So this is a column level details I have selected here, and you can see the column has been profiled here. The infer data types, pattern, value frequency, and the frequent values also you can see here, and the value frequency percentage also you can see here. Okay, this ends the demo here. You can follow this URL to learn more about this scanner. Also, please feel free to share your suggestions and feedback using any of these channels. Thank you so much for your time.